LeetCode problem 144, binary tree preorder traversal. Given the root of a binary tree, return the preorder traversal of its nodes values. Example 1, we're given the following input that looks like this. The output's going to be 1, 2 and 3. Example 2, we're given the following input that looks like this. The output's going to be 1, 2, 4, 5 and 3. We'll cover this example in our walkthrough. The approach that we're going to be taking is called the Iterative Preorder Traversal. It uses the stack data structure, has a time complexity of O of n, a space complexity of O of h, where h is the height of the tree, and it will be the optimal solution to this problem. Now let's walk through the example, where the root is 1, and then the child nodes are 2, 3, 4 and 5. Step 1, declare two variables, stack and result. Stack will be an empty stack and result will be an empty array. Handle an edge case, check if the root equals null, returning the result if it does. Step 2, push root onto the stack. Step 3, while stack is not empty, pop the node off the stack as current node, load the current node's value into the result array, and then push the right child node, then the left child node onto the stack if it's not null. So we push the one node onto the stack, we check if the stack is not empty, which it's not, we then pop the one node off the stack and set that to the current node, we then add the value of the one node to the result, so we add 1 to the result, check if it has a right hand child, which it does, which we can see is the 3 node, so then push the 3 node to the stack, check if the current node has a left node, which it does, which is the 2 node. So push the 2 node to the stack, and then we'll check if the stack is not empty, which it's not. Pop the stack, so the current node is now equal to the 2 node. Add 2, the current value of the node, to the result. Check if the 2 node has a right child, which it does, which is the 5 node. So push the 5 node to the stack. Do the same for the left node. We can see it does have a left node, which is the 4 node. So push the 4 node to the stack. And then while the stack is not empty, we can see it's not empty. Pop the stack, so the current node is now the 4 node. Add the value of the 4 node to the result, so add 4 to the result. Check if the 4 node has a right child, it does not. Check if it has a left child, it does not. And then we check if the stack is not empty again, which it's not. Pop the stack, so we now the current node is the 5 node. Add the value of the 5 node, which is 5, to the result. Check if the 5 node has a right hand child, it does not. Check on the left, there is no left child. The stack is still not empty, so we need to pop the stack, giving us the current node of the 3. So the current node is a 3 node. Add the value of the 3 node to the result, so add 3 to the result. Check if the current node has a right child, it does not. Check if it has a left child, it does not. And then we'll check if the stack is not empty, which we can see the stack is empty, so step 4, return result. The result is 1, 2, 4, 5 and 3, which is exactly what we expected. It's as easy as that. Why not pause the video and try to implement a solution yourself? If not, stay tuned for my solution next. Let's look at LeetCode problem 144, binary tree preorder traversal in Java. So given the root of a binary tree, return the preorder traversal of its nodes values. Example 1, we're given the following input, which looks like this. The output is going to be 1, 2 and 3. Example 2, we're given this input here, which visually looks like this. And preorder traversal, basically you load the root, then you load the left hand side, and then you load the right hand side. So First you load the 1, then you load the left hand side, which is the 2. So 2 is now the root of this subtree. You load the left hand side, which is the 4. So we've done 1, 2, 4, 1, 2, 4. Then you go to the right hand side. So we then go to load the 5. See the 5 here. Then the left, which loads the 6. Then over to the right, which is the 7. So 6 and 7. We've now loaded this left hand side of the tray. So then we come down to the right. We load the 3. So the 3. Then we come down. We load the 8. And then we come down again and we load the 9. So that is pre-order traversal. Example 3, we're given an empty tree where root is equal to null. In that scenario, we're returning an empty array. And then example 4, we're given a single node tree. And in that scenario, we're just returning the value of that single node. So in terms of edge cases, I can think of, or I think there's been 3 edge cases covered in the examples. So example 1, the edge case is where you can see that you've got a node that has a right-hand child but does not have a left-hand child. And you've got another scenario in example 1 where you've got a node that does have a left-hand child but does not have a right-hand child. So that's an edge case that your solution's going to have to be able to handle. Another example of an edge case is shown in example 3, which is where root is equal to null, and we've got an empty tree. In that scenario, you have to return an empty array, and that's because the method specifies that we're returning a list of integers. So we just return an empty list basically. If you were to return null, it's gonna throw an error. And then finally, example 4, which is another edge case, which is where we're given a single node. This is nice and straightforward. You basically just want to return the value of that node. Cool. Now let's get into the solution. So the first thing that we're going to do is we're going to declare a couple of variables. So the first one we're going to do is going to be the stack. So we'll say stack. It's going to have a stack of tree node. We'll call it stack. Set it equal to new stack. Then we want the result, which is going to be a list of integer. This is what we're going to return. So we'll copy that, put it in here. My mistake, put it in here. We'll call that result. We'll set it equal to new array list. Fix this. And then what we want to do is we want to check if root, so if root equals null. If root is equal to null, we just want to return result. And that will handle the edge case, which we can see here. So if root is equal to null, just return an empty array list. So that handles that. Cool. Then what we want to do is we want to, if root is not null, we then want to stack dot push root. And then what we want to do now is we want to loop over each of the nodes in the tree. So we'll say while stack dot is empty. So while stack is not empty, we want to apply the following logic. So we want to set current node, which is going to be a tree node. We'll call it current node equals stack dot pop. We then want to load the current node's value into the result. So result dot add current node dot val. And then what we want to do is we want to check if current node dot write doesn't equal null. If it doesn't equal null, then we want to stack dot push current node dot write, And we want to do the same for the left hand side as well. So we say if current node.left doesn't equal null, then we do stack.push current node.left. And the reason that we're doing this is because if we push the right hand side onto the stack first and then the left hand side second, well, when you pop off the stack, it's going to return the last node that was pushed onto it. And because in Preorder Traversal you want to process the left hand side first, by adding the left hand side as the latter, when you pop it, you're going to get the left hand node before the right hand node, which means you're going to process the left hand side first. So that's why we've done it in this order. Cool. Now once the stack is empty, we're going to break out of the while loop, and that means that we have traversed over every node in the tree. And all we want to do then is return the result and see if it runs. It does, excellent. Now we'll submit it and see how it performs, see if it passes the edge cases, etc. So hit submit. Okay, excellent. It says that it beats 100% in terms of runtime complexity, and it beats 65.45% in terms of memory. So I can tell you that in terms of runtime complexity, it is O of n, and in terms of space complexity, on average, it's O of h, where h is the height of the tree. But if you have an unbalanced tree, the worst case scenario, the space complexity can be O of n. This is the optimal solution to this problem, and I hope that this has clarified the problem and the solution for you. If you like the video, please click like. If you could click subscribe, that's going to hugely help me and the channel out, and hopefully I can get this tutorial out to a wider audience and help more people. And if there's any videos that you'd like to see in the future, or anything that you think I can improve on, please leave them in the comments below and I will get back to you. Thank you very much for watching, and good luck with your coding.